Hi, welcome to session 5, Reactive Programming with Coroutines. In this session, we are going to take a look at what are Kotlin Coroutines, why do we need them, and we're going to see at the end how to combine Kotlin Coroutines with our Java. Okay, so let's get started. What are Kotlin Coroutines? In this video, we're going to take a look at what are Kotlin Coroutines and why do we need them. So why Kotlin Coroutines? As we have discussed previously in this course, it is really important with current state-of-the-art applications to be able to handle I/O operations that are time-consuming properly. Properly means treating them asynchronously and avoiding blocking threads. So if we want to be able to handle a lot of concurrent connections, we shouldn't block threads. We learned how to do this previously on this course using reactive programming. Kotlin coroutines are going to target the same problem that we use our Java or async programming to solve it. And this is to being able to handle a lot of I/O operations, communication with web services, etc. or high time consuming operations on the background. Kotlin coroutines. So you can think of Kotlin coroutines, they allow us to write code that looks synchronously but it runs asynchronously. So you might be wondering what? Okay. So basically, before we see any of the code, what amazed me about Kotlin coroutines is that it takes out all the complexity of, for example, our Java or making callbacks of features by letting us writing our code synchronously like we wrote before, so we don't have to learn new operators or anything like that to run it asynchronously. Pretty amazing, right? So basically, with Kotlin coroutines, you don't have to learn anything new. You just need to learn just a couple of small things. In terms of code, it's going to look the same as synchronously code. How this magic happens. Kotlin coroutines, we use what is called suspending functions. And a suspending function, by syntax, we just add the keyword suspend before the keyword fun in the function signature. This makes the function suspending. Suspending function suspends a coroutine and it releases the thread of execution. So basically the same as asynchronous programming. They don't block the thread that calls it. Very good option for scaling, of course. And they can only be used inside another suspending functions. This is very important. So we cannot call suspending functions directly on our code. They have to be called inside another coroutine. So you might be wondering how we do this, how we create a coroutine. As I said before, coroutines can be called only inside a suspending function. Kotlin Coroutine library provides us different functions to launch coroutines. One of the most used ones is launch. Launch starts a coroutine. It has predefined default parameters that are the context, the start, the parent job. But the most important is the block parameter. The block parameter allows to define a suspending function inside it. This is what we're going to use the remaining of this session to work with coroutines. Okay? So don't worry if this is kind of confusing. We're going to see how to work with coroutines.